Hi, I'm Jesse Dringoli with Bentley Technical Support. Did you know that if you have SewerGEMS, you also have SewerCAT and StormCAT? The functionality and numerical solvers of these products are included with SewerGEMS, and the ability to do things such as automatically design pipes and perform a peak flow analysis without having to convert your model or open it in another product. So in this short video, we're going to cover two models, one a small wastewater model and one a stormwater model. So in your case, you might have an existing model that you made in SewerGEMS, such as this one, with a default implicit numerical solver, where you took a look at some time-varying flows, such as, for example, if we graph this wet well, we can see the flow in, flow out, and hydraulic grade over time. However, you might have a need to do, say, a peak flow analysis in steady state using extreme flow factors to look at your peak conditions. So what you can do is go to Analysis, Compute Center, and let's dock this over here on the left side. And you can change the active numerical solver from implicit to GVF convex. So this is the solver in SewerCAD. So in this case, we can take a look at the extreme flow factors, and you can see we've set up several extreme flow methods to peak the flows. So if we compute the model, we can take a look at things such as the population. As we move upstream, you can see that this is different, and the resulting flows are calculated with that. Maybe we can take a look at a profile and see how this differs in a peak flow situation versus your time-varying dynamic analysis. So here's another example, this time a stormwater model. Now with the implicit solver, you can do things such as size your pond and take a look at flow and hydraulic grade and other things over time, as you can see. But you might have a need to size your pipes based on the standard rational method. So what you can do is switch to the active numerical solver to the GVF rational. Now over in the Compute Center, what I've done already is set up a rational scenario that has the active numerical solver set and also has the catchment set up to use the rational method. We can also take a look here at the design constraints. So we can see there's velocity, cover, and slope constraints. And if we look at the conduit catalog, we can see that there's several pipe sizes available. So initially we can see in the conduit properties that we have a size of 10" for everything. But if we go ahead and do calculate, and I'm going to choose no when asked to create a new alternative, that will go through the automated design routine and size the pipes and inverts accordingly. So now we can look and see that our pipe sizes have changed. We got 12, 8, 12, 15, and if we take a look at a profile here, we can see that the pipes have been sized and the inverts moved accordingly. Now I can take those sized pipes and go back to the other solver if I'd like. So I can change the active numerical solver, or in this case I'm just going to switch back to the implicit scenario, which uses the same physical alternative. So we're using the same pipe sizes, and then compute that again. And then we'll be able to see the effect of our new design. So if I look at our pond here, I can see how that affects the pond, and then I can also look at profiles. So here's a help topic that may help you for any other questions you have on switching between solvers. Thanks for your time.